This lesson is going to be looking at how to use the slope and y-intercept form to draw the graph of a line. Now, quick reminder, slope y-intercept form is y equals mx plus b, where the m is our measure of the slope and b is our y-intercept, so where it crosses the y-axis. So if we know the equation in that form, we can rearrange it, in any form, we can rearrange it to find slope and intercept, which we can use for graphing. So we've got a couple examples here. We're going to look through 3 of them. First, we're going to rearrange each of them into slope-intercept form, and then we're going to use that slope and intercept to graph each of the 3 equations. So our first one, y equals 1/2 x minus 12. Well, what form is it in? If you look, y is already alone. So when the y is alone, our slope is whatever's in front of our x, and our intercept is the value that is the constant all by itself. So already in slope-intercept form, so our slope is our number in front of the x. So in this case, that's going to be 1/2. And our intercept is going to be -12. So be careful with your signs, it makes a big difference. Second equation, is that one in slope-intercept form? It's not, because we have the x and the y together on one side. Not only that, the y that has a coefficient that's not just 1. Right? Slope-intercept form, the y has to be completely by itself. So first thing we got to do is get this into y-intercept form. Well, if we want to get the y completely by itself, we're going to take that equation and we're going to subtract the 5x so that it's on the other side. So we end up with 7y equals -5x plus 14. Well, now the y is on one side by itself, but it's not truly alone. We have to get rid of that 7. So to get rid of a coefficient, we divide by 7. And whatever we divide one side by, we've got to divide both sides by. So 7y divided by 7, 5x divided by 7, and 14 divided by 7. So we're left with y equals -5/7. Watch your signs. Oh, but got a mistake there, so we got to better put an x on that. -5/7 x plus 2. So again, our slope is whatever in front of the x, and our intercept is whatever by itself. So it's in front of the x, the -5/7. So we change that to -5/7, and we change the b to 2, our number all by itself. So now that one's in slope-intercept form, y equals mx plus b. Same as our first one. Third one's also not in slope-intercept form. If you look closely, you can figure out which form this one's in. We've got y minus a number, so y minus y1 equals mx minus a number, x minus x1. So this is in point slope form. So again, the y is not alone. Not only that, we have some brackets. So first step is going to be get rid of those brackets. So multiply the 2 through, we get 2x plus 10 on the right hand side. Then we need to get the y by itself. So it's close to being by itself. There's no coefficient in front of it, but we've got to get rid of the -3. So when we move that to the other side, we're going to add 3 to both sides, cancels on the left, and we add it on the right to get 2x plus 13. So our intercept, number all by itself, the 13, and our slope, the number in front of our x, 2. So let's get those values up. So now we have all 3 lines in slope-intercept form. So once these are in slope-intercept form, we can take those 2 pieces of information and draw a graph. So the first one, we've got a slope of -12 and an intercept of 1/2. So on our grid, I've scaled it so that every 2 squares is 2, so I can get all the way down to -12. We do need to put an axis on there. Mine's a little bit crooked, but it's as straight as I could get it. And we're going to use that axis to label what we have where. So I've got myself some dots so we can put these in here. So unlike when we're graphing individual points using their coordinates, when we're using slope-intercept, we're going to start with the slope, and we're not going to count from the center. We're going to start with the intercept, and we're not going to count from the center. We're going to count from the point we've got. So for that first one, our intercept is minus 12, so we're going to put a point right at minus 12. And from that minus 12, we're going to count up 1 and over 2, because remember our slope is rise over run. So the top number is the rise, how much we go up or down, and the bottom number is the run, how much we go over. So we're going to go up 1 and over 2. Now since I use the same scale on both sides, I can either go up 1 square and over 2 squares, or I can go up 1 value, which is half a square, and over 2 values, which is a full square. So I can either put my next point up 1 over 2 like this, or I could put it as up 1 and over 2, complete squares. Notice it really doesn't matter which way you do this, because they're still ending up on that same line. So once we have these points, we can do this as many times as we want. We can keep going up 1 and over 2, up 1 and over 2. My point got moved here, so let's move that back. And really we need to do this a minimum of 3 times. We could also go the other direction. Say this was at the very top of my graph and I'm like, it doesn't fit on my screen. It doesn't fit on my graph. I could also go, instead of that last one being up 1 and over 2, I could have said, well, let's go down 1 and over 2. And that would have been fine as well. Either way, I can see, okay, I've got a nice straight line and I can connect the dots. So use your straight edge, use a ruler, and play connect the dots. So I had this one on earlier, so this is pretty close to going on those points. One little trick I like to use, if you do have some points that are right on your coordinate grid, use that pattern. So this one's on my coordinate grid, this one is, my next one should be there, my next one should be there. So when I'm lining up an actual ruler, I do that. Don't forget to put your arrows on each end and label your equation. Usually we go with the original equation, even if we end up rearranging the equation to be some other format. So there's our first one. Our second one, well, when we look at this format, we can't see our slope and intercept. So back to our work. Our slope was minus 5/7. Our intercept was 2. So we're going to start at 2 for that one. So we take that point and we're going to put it right at 2, as near as we can get it. And from there we're going to go minus 5/7. So the top, our rise is minus 5 and our run is 7. So a rise of minus 5 actually means we're going down. So we're going to go from that point down 5. So remember this is 2, 4, 5, and over 7, 2, 4, 6, 7. So we end up kind of in the middle of our grid here because I am using a scale of 2, and we've got that point. Now if we take our second point and go same pattern, so from the point we've got, we go down 5 and over 7, so it's going to be right there. And again, that point, if it ends up being off your chart because you've used a different scale and you're like, I can't make it fit, your other option is to say, let's go exactly the opposite. So instead of down 5 and right to the 7, we could go up 5 and over 7. So I'd be right in the middle of that square. So once I have that point, again, I'm going to draw a line. So I want to make it all line up really nicely. And again, if I have some points right on the line, that's kind of a handy thing to be able to use. Feel like I made a mistake. Just because my whole thing won't move at once. So that looks about right. No, it doesn't, because it's not going through all 3 points. Okay, so let's see if I made a mistake. So up 5, 2, 4, 5, and over 7, 2, 4, 6, 7. Yeah, that was right. Down 5, 2, 4, 5, 2, 4, 6, 7. I just need to work on my line. There we go, that's better. Hitting all 3 points. So once we have all those points in there, again, don't forget to put your arrows and don't forget to label your line. So you'll notice I'm using my labels so that they match the diagram, the colors I was using up here, and also my equation. I can see which line is being labeled by which equation. So the third one, we had a slope of 2 and an intercept of 13. So our first point starts with 13. And then my slope is 2, so remember that means 2 over 1. So rise is going to be 2, run is going to be 1. So from that point, I want to go up 2 and over 1. And again, don't forget the scale here. So there, that's up 2 and over 1. And I can see my next one's pretty close to off the graph, so instead of going up 2 and over 1, I'm going to go the opposite direction. So down 2 and over 1 the other direction. And from there, I can put my line in here. Gonna have to do a little adjustment so it hits my points. Words being a little finicky and flashing on you there, sorry about that. So there I have that line, and I can label my line. Again, don't forget the arrows on either end. So sometimes we only want to draw one line on a graph, sometimes we want to draw a whole bunch of lines like we did right here, but that's how we can go about doing it. Our other method of drawing a line on a graph is still going to work. Remember, that was using coordinates that are on, so find some x's, figure out the corresponding y's, find some y's, figure out the corresponding x's, and draw it. Still doing the same things in terms of connecting our dots, putting arrows on either end of the line, and labeling our graph. So that's our quick graphing a line using slope and intercept method.